Yeah, I'm Brenda Marshall. There's my email address as well. Also on the back of those brochures, the booklet, Wolfram in Education brochures, those have my contact information on the back as well. If you didn't get one of those, please write it down, because if you have a question after I'm done that you'd like me to answer, I ask that you email them, or if there's any questions that come up through the talk that I'm just not able to answer. I do have wonderful resources at the home office, and I like to get an email so I don't lose anything in the translation. Okay? I am going to give a broad overview of Wolfram technologies, the Wolfram language, Mathematica, and how you can use it in teaching applications, how you can use it in research applications. You will notice that the presentation is going to be done entirely in Mathematica. So I like to make sure that you realize that, because this is a wonderful computation tool. And I saw this quote about that. But it's also a wonderful presentation tool, and it's also a wonderful publication tool. So if you're publishing, if you're doing talks or conferences or lectures, as the professors here probably do, you can certainly do everything from Mathematica. So that's a nice one-stop shop for you, so you don't have to keep going back and forth to softwares and trying to interact and get things to work together and that sort of thing. So I'm going to jump into some things, and also I said a broad overview. I'm not going to delve deeply into any one subject, so I'm just kind of like trying to give you a vision. You guys know your areas of expertise far better than I do, so I can try to give you a vision of what you can do. Okay? So I'll give you a little bit of the history. I know this is kind of small, but fully 100% of the world's top 200 universities are using Mathematica. So, and you all as well, to a small degree. I'd love to see you have a larger availability for your students and your faculty. But there's Mathematica is out there in a big way. Not only that, once your students leave, wherever they're going to, fully 100% of the Fortune 50 companies are using Mathematica. All of the national labs, all of the military institutions, the Army, Navy, Air Force, Marines, NASA, all of these places are using Mathematica. So this is something you'll see, your students will see after they leave here. So, and you students will see after you leave here. It's certainly got its roots in academia. Stephen Wolfram, Jonathan's met him, or sorry, David has met him. He is still heavily involved in the company. This man is in my opinion, true genius, but he's one of these people that never turns off. it's a very dynamic individual if you do get to meet him. And he is big in this, and now his son Christopher has started to get involved in the company as well. He's younger than all of you, I'm sure. It's like 15 or 16. It's pretty amazing what he can do already. So our flagship product is Mathematica, but I'm going to get into Wolfram Alpha, which came out in 2009, and that's about the same time I started with the company. I started in 2009 with version 7, and at that point all we had for getting it started in Mathematica was the point-and-click technology to kind of get you through the learning curve, and now we've got so many ways to make it so much easier for you, so I'm going to get into some of that. So just to show you, a quick illustration of how Mathematica kind of evolves. With the initial Mathematica, you had uses in business and finance, business a little bit at that time, physical science, math, of course, statistics, computer science, etc. But when we threw in alpha into the mix, that really shook things up and really added a lot of ways to use curated data, Mathematica, Wolfram Alpha. So now you have political science, language science, meteorology, linguistics, history, etc. So you can see how it's really grown its applications. And now we've thrown Mathematica Online into this, and that gives you more avenues to access this information and use it through other devices like tablets and iPhones and things like that. So the Wolfram language is a knowledge-based language, very large scope of any, or one of the largest scopes of any language out there. Wolfram Cloud made it even more browser-based and more abilities to deploy and do APIs and things like that. So, and this is just an example of one API that was done at a hackathon in University of Michigan, just a little drawing app. So starting with alpha, I'm going to kind of give you a vision of how you can flow into A, your workflow, B, your learning curve, and that sort of thing. Who else used alpha? Who knows what it is? Yes? Okay. Even if you have not used alpha, I bet you are familiar with it, and everybody knows what Siri is, right? Okay, when you ask Siri a question, it's going out to her. She's going out to alpha to find it. So 90% probably of the time. Anything that's computable, geographical, anything like that, it's data type thing, it's going to be alpha. And you can see right here, if you ever look at your phone when you're asking those questions, it's going to be our logo right there, that Wolfram Alpha logo. So, and this would be a typical question that you would ask Siri or look up on your iPhone like that. And when you ask a question like that, you use, and this is actually the Wolfram Alpha website. This is on your computer, how you access it, or on your app on your phone. Okay, so this is Wolfram Alpha, and you would ask a question, or you would pose it more in natural language, right? If you were in alpha. That's great, and that's the results you would get, and we love that. Very easy to use. And that also gives you a segue into how to get started in Mathematica and make it very easy for you to get started, because we have integrated that free-form input into Mathematica by using the equal sign. So if I was going to get that same plot sine of x, I would just type the equal sign, and that would give me that little orange box. Get that a little taller. So that would give me that little orange box, and I would just say plot sine of x. And it says, okay, you didn't give me a range, but I'm going to parse this into Mathematica syntax, and I'm going to try to figure out what you want. So it gives me a nice range of -6.6 to 6.6. It gives me that Mathematica syntax, that Wolfram language, right? So now I can just click on it and bring it into Mathematica and start working with it from there. So it's very easy to get started these days, and I can change things up, make it up, anything, and get a different result. It's very forgiving. If I wanted to do the same thing and say graph syntax or sync, you know, discrete fine. But anyway, it did that. Let me try this again. Let me do sine. Still did a nice graph, but I want to keep on the same flow here. Anyway, so if I did that sort of search in a Google browser or something like that, I might get some porn sites, or gosh, I have no idea what you would get. But because it's alpha, and it's going to our alpha servers to get this information, it makes some mathematical assumptions about what you want, and it goes into that data mindset. Okay, so I could do something like an integral as well. And this is what's nice about having this interface with alpha in Mathematica. You have this, it gives me my result, it gives me the Wolfram language, but it also gives me this little plus sign that I can click on. And what that does then is goes out and gets that alpha part of things and gives me all this peripheral information that it can find, anything it can find. And so it gives me the plot of that integral, gives me an alternate form of it. It gives me step-by-step solutions up there. So you can click on that and get step-by-step solutions of that integral. So nice little tool for students and faculty. You guys are kind of, here's students, here's faculty. So it's kind of funny. Another nice thing that we're doing with Mathematica to help you get started is this. It's the suggestion bar. Now this just came out in 10. No, not 9. 10. Yeah. No, 9. I guess it did in 9. 9. The suggestion bar. Anyway.
9.0.
Yeah, so it's pretty new. What this does is it makes, again, mathematical assumptions and says, okay, somebody that does this sort of equation, what their next step might be. And it gives you suggestions of what your next step might be. So I can go in here and say, okay, give me the derivative of that. Plot it for me. There's even more under here. So I could do the background, change it to gray. I could do axes of white. And each time it's coaching me, it's helping me get started in the Wolfram language and in Mathematica. So it's showing me what those that syntax is on each of those. But once I get to a point where I'm like, oh, that's what I want it to look like. This is perfect. This is what I want. I need to get all of that into one nice little succinct command. So now you just click on this, which is the roll-up inputs, and it says, okay, here's everything that you've done above into one command. So it wraps it all up for you. Another thing we do is the autocomplete type suggestions. So if you can't remember what a function is called, you just start typing what you think it is, and it starts to give you suggestions of what it has that are similar to that. So things like this, or what have you. So having shown you how easy it is to get started with Mathematica, another thing that the 3 simple rules that get you going are right here. And the rules are you capitalize your function name, you put square brackets around what you want to solve, or your arguments, and you put curly braces around your lists and ranges. So it's very easy. Those 3 steps get you going in Mathematica, and you just build on that. Another thing that we had, this came out in 7, it's still pertinent today. So this point-and-click palette, using point-and-click technology to get you going is still relevant today. This classroom assistant palette can be your best friend too. If not doing the math part of it, then doing a presentation out of this, because it has all your writing formats, how you want to start each cell, whether it be a section cell, title cell. It has your math type here. It has a keyboard here. If you're working on a smartboard or something like that, it's a great tool to use just to work everything from up front there. But if you're just trying to get started, this is what it was first designed for. So if I wanted to do that same plot, I would just say 2D, click on that, and it gives me that template to start with the actual syntax of the language. So if I wanted to put that as a cosine, right? X, where X goes from. I'm just doing this with my mouse. Ta-da. So you can do that with this. You can do other things like put in axes, fill to the line, to the axes. You can do, put in grid lines, fill to the axes. Things like that are available if you're change colors, if you do all kinds of things. Okay, I did the implicit system. Then the last helpful getting started type of thing that I've got for you is the documentation center. And this is basically the Mathematica manual. If we were to print this these days, it would be this thick. So this to the floor, guys. But it's just, there's so much in it. So what you can do is you can go in by topic here, or you could go in by word search. I'm just going to stick with the plot thing again. So you could go choose a plot. Once you get in here, then it's got that Mathematica, that Wolfram language. It's got examples, it's got details, it's got tutorials, it's got all kinds of things. But what's really nice about this is that this is Mathematica, it's live, it's working. So if you find a sample or an example that's close, you can just change it up right there and make it your own, and then just copy and paste that into your notebook. Very easily. So then you don't have to retype all of that stuff and try to figure it all out. Mathematica Online is very new. It just came out in the last year, not even a whole year. It came out at the end of last year. So what that enables you to do, it's going to look just very much like your desktop version. You won't notice any difference here as far as once you're inside of a notebook and working. It will look a little different on the welcome screen. There's that community you were talking about. I highly recommend, if you're using Mathematica and you have any issues, get into this community. It's just a forum. It's just a chat forum type of setup where you can ask questions. Our techies are in there all the time. And other people, other users that might be doing the same thing you are in there all the time. And just answering questions, asking questions, things like that. One of the big topics right now that I've noticed is 3D printing, and also cloud technology, doing things, deploying things, doing stuff like that is really big in the community right now. But that's a great place to go. It's on your Mathematica Online reading screen, but it's also on Wolfram.com, so you can go in there and find it. So what's great about the Mathematica Online is that it enables you to use Mathematica via a web browser, so you don't have to have it loaded onto your computer or your tablet or your iPad or iPhone. You can use it that way. Okay, I'm going to bring concepts to life. I don't know if y'all have been doing this yet, but you can build models with Mathematica. And the model building tool is called Manipulate. So if I did this sine curve again, I could bring that to life and investigate frequency on that sine curve just like this. And there it's helping me again, suggesting what I want to do. So if I want to investigate frequency, I just go FREQ. And it's also coaching me this whole time too. Oh, okay. Like this is purple, that means I haven't closed my bracket. Have you guys started using Mathematica at all? So you're familiar with this, I won't get into all that, but it's coaches you as you go through, you know you're missing something. So, I'm going to tell it that I want FREQ to go from 1.5. So now I get a slider bar to investigate frequency on that sine curve. And I also have this little model building tool that will run that model while I'm talking about it. And I don't know if you've investigated this yet, but it'll let you go faster and slower, pause it. And if somebody should ask you what frequency looks like at maybe 4.44444, you can plug in an exact result. And even if somebody were to ask you what it looked like at 9, it's going to say, okay, red light, this is outside what you've defined, however, I'm still going to show you what it looks like. So it's very nice in that respect. I could also look at more than one function if I wanted to. So if I do functions and I do sine, cosine, tangent, cotangent, secant, and cosecant, it's going to give me the ability to look at all those functions on the same plot and manipulate those as well. Now I did 6 on purpose because after 5, Mathematica does something very nice for you. With 5, it gave me button, right? Okay. If I do one more, it intuitively knows that things are getting a little cluttered, a little, too much stuff going on. It's going to keep things as aesthetically pleasing as possible and give me a drop-down menu automatically. So I don't have to program that in. Dare you to do that on MATLAB. Anyway, it's a great tool for that type of thing, and I'm going to show you some other things that it does intuitively too as I get along here. It just saves a lot of time when you're trying to do this sort of thing. And you can make models out of anything. Here's an expand a plus b to the 5th. If I wanted to make a model out of that and say expand a plus b to the nth, and I say n is going to go from 1 to 100 in increments of 1, I can make a nice little expansion model. And again, I could plug in that exact result and do it that way. I could do a histogram, and then this is just a normal distribution. And if I wanted to make that come to life and go from 100 to 10,000 in increments of 100, I can do that this way. Or this is very basic. This is an X nested in frames, 6 frames right there. If I wanted to make it nest in 1 to 25 frames, I can make that grow as well. Now that model I showed you, the first model I showed you, where we did frequency, I could do something and expand on that a little bit. And this is showing the amplitude as well as frequency and horizontal shift and vertical shift on all of those different functions as well. So that's pretty, I mean, you can do this. This is very easy stuff. You can do this. But you don't really have to get started that way. And this is just showing what it looks like. It looks the same in Mathematica Online. You can go to the demonstrations projects. Have any of you guys used that yet? Anybody? You gotta be kidding me. Oh my gosh, this is so cool. Okay, this is right now free on our website, wolfram.com, demonstrations project. There are 10,303 models on here that are already been built for you. You can use them. You can do anything you want with them. So if I were to go in, I can go in by topic, like I did the documentation center, or I can go in by word search. So if I stuck on that tangent line model that I was working on earlier, and I needed a model for that, I'm going to try and grab one. I've been having internet issues with Word. Well, I don't know why. It just doesn't want to bring things in fast enough for me. I need something faster. I don't want to do it. There, it does. Oh, it will. It just takes a little time. I don't know why. This one, and this is much more dynamic than that first one I pulled up. This one comes up. That one didn't come up. Okay. So anyway, what it does, and all of these models are donated by users. They're submitted by users, whether they be students, faculty, corporations, whatever. They send them to us. We go through them with a fine-tooth comb, make sure that they're going to do what they're supposed to do. We add a couple of lines of text on the bottom so that it tells what it's illustrating. Okay, and then we also give you all credit for what you've done. So in the citation does name the person that submitted it. So it's a pivotal way for them to get published. So you as students come up with something cool. This is something to put on your resume that will help you as you're moving into the real world. Not that academia isn't the real world, guys. It's real. It's very real and painful. There you go. So anyway, you can use the slider bars right here from our website, or you can save it as a CDF file, put it on a flash drive or something like that, and use it just using the CDF software. That's fine. But if you really want it, and you like a model, and you're like, oh, it's just so close, but I really want it to do something else, you can download the source codes, because you guys have Mathematica. You can download it into your Mathematica and have it right here. And then you can go in and you can say, okay, I want this to look, I want it to do it in fifth order instead of second. So now I go in and evaluate that, and now I've changed that a little bit. I mean, I can change it a lot if I want to add to it, subtract from it, whatever I want to do. But you can use that code. This is open source once it gets on that website for Mathematica users. Now, I mentioned the CDF technology. That stands for Computable Data Format. Okay, have you guys used that at all? Do you use it? Okay, here's how you might, in the future, something like this. But what's really nice about Mathematica and the Wolfram language and what we do for you is that if you do something in Mathematica and you want to share it with somebody that does not have Mathematica, you save it as the CDF player or the CDF document, and then you can send it to whomever that doesn't have it. You can then they can download the player software for free from our website and open your document, read it, work the manipulates the models and everything, and but they can't change any of the code. Okay, a very clear illustration of how this is used is with the Pearson e-calculus books. Those are all done in Mathematica. And the way that the students access that is through the CDF player, and they work our models, and that's all live. That is not a PDF, that's all live, working models, working, interactive, everything. So really the beauty of that too, though, is if those students have Mathematica, all of that stuff is in that textbook. They can download those models and open them up in Mathematica and then expand on that and start to grow from that. And that's something that you guys can do. Oh, so just to give you an idea of what's in Mathematica, this is a great place to go and see that. Chemistry is right here. Oops, if I can spell it right, it's right here. So we already have 739 chemistry models in here that you all are able to use right now. Are you guys just coming in?
Yes.
Can you sign in for me, please? There's a sign-in sheet. Thank you. That's all right. I just don't want to miss. Oh, the reason I have you sign in. Sorry, guys, I forgot to tell you this. I'm not just being anal. It's that I will be sending out this notebook that I'm using for my talk, so that you can go through it if you'd like to. So I am going to send it to you, so you can play with it, use it, whatever you want to do. Take pieces out of it. I don't care. Okay, so chemistry. What else do we have here? Biology.
You see a brief brochure?
What was that?
The reaction.
Oh, I just went to biology. I'll go back to 253 models in biology. So what was that?
That Briggs brochure mechanism, the chemical color clock, the second row.
Second row. This?
No,
This
up
one?
down.
Okay. Oh, Briggs brochure. I don't know if this will open. I can try it. There we go. So yeah, I'm able to get the actual pictures. That's kind of cool. Is it changing? It's not keeping up very well, is what it's not doing. Okay, let me get some other ones. We did biology. So what else do we have in here? Music? I mean, physics.
We have biology, chemistry.
Physics, there's like 5 million physics. Okay, we do that. Physics and math are just like a given in Mathematica. It's just like so many. 1975 physics books. Yeah. You said astronomy? 200 astronomy books. We like astronomy. And it's growing because we have more data that we curate, the more that people are going to use that. And which I'm going to do, I'm going to move forward here. I'll show you something. Okay, moving on.
A question, what do you do, like you have your data on Excel and you throw your Excel spreadsheet into it?
And I can show you, I'm going to get to that, just that you can input your own data, absolutely, absolutely, we encourage that. Getting started, interactive documents, okay. One of the nice things, I told you that this is a slideshow that I've done in Mathematica. You can create your own, and you can start your own, and you actually put some templates in there for when you get started. I can't do it to show it because I have to start a new number, but they're kind of like Excel does, or not Excel, PowerPoint does when you start reading for a little background. It's kind of like that, only we actually format those cells for you and stuff, so it's nice. And we also look very much like your textbooks. You've noticed that some of my Wolfram language back there is kind of Mathematica-ish. Well, we also can do mathematics, so we can make it look just like your textbooks. So that's that publication aspect of it. And then I think I do have an example here. So that's just to show you what something might look like using Mathematica. I'm going to jump into Mathematica Online real quick, just show you what it looks like so you don't get scared and can't use it. And this is also a place that you can share documents if you're using Mathematica Online. You can put something on there and have it available for somebody else to go and grab it online. So if you do not have the online capabilities yet, it's something we could add on. Guy. But you can see it looks very similar to what you've seen me doing already. Okay, I won't move that just yet. Curated data. Well, I think I will. I'm going to jump into, before I get into curated data, I'm going to jump into Wolfram Alpha. If you haven't used that yet, I'm just going to, then some people have not, I'm just going to show you what you can do right now. Now, Wolfram Alpha is a computational knowledge engine, right? So we know it's not, I kind of gave you an example of how it's not like Google as a browser. It's more like Wolfram Alpha. I don't think there's anything else like it out there. That's my point, I guess. So when I put in a query like Big Dipper, unlike Google that would give me kitchen stores and it would give me who knows what all else, Wolfram Alpha is going to make some very clear and mathematical assumptions that you don't want that sort of thing, that you're looking for Ursa Major, and you're looking for the Big Dipper. And it's going to give you little pods of information on whatever I'm looking for. And you saw that with the integral I did. It gives me little sections of information on that integral. It does the same thing with something like Big Dipper, going to astronomy here. And so it's going to give me what the bright stars are in it. And also will ping me on my URL. Notice I'm in Miami, and it's going to show me where it is in the night sky tonight. So it shows when it rises and sets, and things like that. So it gives me anything it can find, any pertinent information that you're going to like. If I did something like, St.Thomas University. Yeah. All right. Hold that up.
It took a while.
Well, you're small. So it gives me, all this information. It pulls up anything that you guys have put out there on the internet about yourselves, or anybody else has put out there about you. Statistics or data that they put out there or anything like that. So yeah, you don't have much on here. Yeah, there should be more. Yeah, you should have your majors and minors and stuff.
Yeah.
It says, because I actually pulled it up before that to see what you guys were all about. There we go. So it's going to have your enrollment, it's going to have your tuition, it's going to have your different degrees that you grant, and how many students in each of those, and how many you actually graduate each year, things like that. So I give your accrediting agency is things like that. Pretty cool, huh? So there's all kinds of things in here. Now, that's just free. That's all free stuff. There is the pro side of Alpha. That's the kind of paying side. I don't know if any of you guys are subscribing to it yet. But the nice part about the pro thing of it is that you can do problem generators. You can also import data, small amounts of data in Alpha. It's not a really big number cruncher because that's not what it's designed for. But you could plot some small graphs and do some interactive graphs and things like that. And you could download an image of a picture and do some image processing on it, processing. But it's it's good, but it's very basic, very high school more focus. But anyway, this is very nice though for students to get started just practicing. And these are the 6 areas that we had problem generators set up in. So if I wanted to get into algebra, for instance, and I wanted to multiply some radicals, it's just going to throw up a random problem for me, and I'm going to try to answer it. Not very well, but it'll say, okay, you're wrong. I'm not wrong. Like I said, doing that here is not great. Oh, and it also gives me, if I want beginner, intermediate, or advanced up there, I can pour my difficulty levels. Sorry, guys. While I'm waiting for that, it also, it'll do individual problems, but it'll also do random sets right here when I get to that point. And then I can get a set of 20 problems that you could use for quizzes or something like that. So it's kind of nice to do things like that.
When you get the app from the internet, the one that you get from the Apple Store, that's not the Pro. Or it's not
No, the Wolfram Alpha app, that's just plain Alpha. Yeah, that's just to do questions and.
Because the Pro, there's no app for the Pro. Or the app for the Pro, you need to get access to the internet.
I'd have to look. That's going to be on here, so I'll look. But I think you have to. I don't know that you can use the Pro on it. I don't know.
Because I have a Wolfram Alpha in my iPad, but I never got the random, so the generator, the program generator, I was trying to find it, and I couldn't find it. I think that's the program.
Yeah, it's not going to be on just regular Wolfram Alpha, definitely.
Okay.
But I'll have to look at that just a second. Anyway, you get 20 problems in this random set generator. You can do it as a PDF, download it as a PDF and print it, or and we also have the answer key here as well for you, so you guys don't have to do any work. Let me move on here. Okay, curated data. This is what Alpha started, and we're still building on this. So these are the different areas that we have curated data in: chemical, biological, physics, astronomical, mathematical, socioeconomic, geographical, and financial data. So to get data, I can just use that equal sign like I showed you earlier. That every time you see that square equal sign, that means you're going out to our Alpha servers, and you would need an internet connection for that, so keep that in mind. So you're using freeform inputs. You can't just be on a standalone computer without internet access. Okay. Once you get something, data or something like that, you can certainly save it and use it again and again and go out of your time. And certainly the melting point of caffeine is something that would be very easy to use again and again. If I wanted to look at the molecule of caffeine, I can pull that up as well, and it looks like that. If I wanted to ask Mathematica, what chemicals do you know about? Here's the chemical data. I just did that's my Wolfram language query for this data, and it says that it knows about 44,067 different chemicals. And of those chemicals, it knows these properties. And that melting point is there and stuff like that. And this molecule plot would be there as well. And the nice thing about something like this, it's 3D, so it's OpenGL. You can look at it and you like, and you can zoom in on it. Here's some other data that we could look at. This is the literary fraction of Zimbabwe. Here's a bar chart of the literary fraction of Africa. And then if I wanted to do more than one continent, I could certainly do something like this. It's more interactive. Now, this is pretty basic. I've done others where I took the each of the countries and put their flags, so every time I moused over, you'd see the flag of the country and the literary fraction. It was kind of fun. That's what you actually this geographics, what it's doing is it's pinging me, finding out where I am, and showing me where I am. So it's basically showing the tower that I'm, my URL is pinging on. I was using my Verizon wireless card the other day and did this because I couldn't get internet access to one of the colleges I was at. It was pinging out of New York. It was kind of interesting. You don't expect that, but it could be anywhere. Anyways, this is flashing. Okay, this is using those flags I used earlier, but I like my part of it. Anyway, it's using flags and putting them on each of the countries of Africa. Now here's where you were asking about your own data and downloading your own data. Absolutely, you can just download an Excel spreadsheet, not a problem. We took it, and here's other supported files, and you can look at these when you get this notebook as well. But excuse me. We took it one step farther. I usually show an example of just bringing in an Excel spreadsheet. But what we did was we took these data points and we dumped in a data drop. Data drop is something new that Wolfram has come out with, and it's very nice for you guys that already have Mathematica. You can drop data into data drop on our cloud, and then go and get it later. Now you can't leave it there forever. You can only leave it there for a short period of time. We are kind of judicious with our cloud credits, but you can dump it there if you're gleaning, trying to get some data, data mining off the internet or something like that, and you have it and you throw it in there and you go. And then it gives it a bin, puts it in a bin, gives it a name. So I can go and get that bin back in Mathematica, and then I can pull out those values in that bin, which you'll notice those are the same as these up here. And that was an Excel spreadsheet, by the way. And then I can plot that data very quickly. So that's a couple of different ways to do it. And remember this graph, I'm going to use it again later with mom. Okay, visualizing things. I'm not visualizing things, it's symbolic computation. That is our backbone, that's what we got started with. And I don't know if Stephen told you this. Did he tell you that he did math?
I think we were chatting. He started. He was having trouble with Feynman integrals that he was doing for his PhD.
Yeah, he said it. He goes, I'm not good at math. I saw him do a talk on this. He said, I'm not good at math. Don't like it. That's why I designed Mathematica, so it can do the math for me. So this is what you do when you start thinking hard. You're thinking of ways to get out of working. So these are some of the symbolics capabilities, just to give you some examples. And you saw, this is just a little physics example. This is the displacement of linear down pendulum. What happens when the Abelian factor is applied? An illustration of that. Numerics, who's doing numerics? You're doing, okay, you said you were doing numerics. Okay, well, you know, you understand all of this now. And ND-solve, are you using ND-solve?
Yeah.
Just so you know just a quick touch on this. ND-solve is like a super function in Mathematica. So if you don't know which function to use for your numerics, you wrap ND-solve around it, and it kind of goes out and figures it out which function to use for you, so you don't have to sit and stress over it. Now, my engineer guys will say, I want to know what function I want to use. They go, hey, you can go do it yourself, that's fine. But if you don't want to, and then I told him, I said, well, okay, that's fine. Then why don't you just do ND-solve to start, to kind of get an idea of where you want to go, and then go from there. Do what you want to do. And this is a really kind of cool example of how heat distributes over the shuttle as it flies through the atmosphere. Linear algebra, of course, we do that as well, dense matrices, using industry standard high performance libraries. And we do support any standard matrix operations. And here are some examples of those. Let me whip through these because I'm going to show you again a very clear and simple illustration of letting computers do all the work. Computer-based math. Stephen and Conrad Wolfram do a lot of talks in TED Talks and things like that. If you get into those and look at them. They talk about computer-based math, and what that really means is letting computers do what computers are meant to do, and that's the grunt work, that's the hard work, that's the time-consuming work. Okay, so that you can get on to bigger and better thinking. This is a kind of very basic and clear illustration of that. To numerically approximate that inverse matrix would take some time with tools that, well, you guys have my better, with other tools. And just to illustrate how quickly Mathematica can do something like that, and is our shortcut for numerically approximate. Percent signs means use my last output as my new input. If you guys are already using Mathematica, hopefully you're familiar with that little shortcut. If you're not, because this makes life much easier, so you don't have to copy and paste anything, and that's how fast you can numerically approximate numbers like that. So that's computer-based math. Units, we do support all standard units now. Just came out in 9, I think, was units. We're probably, I think we're the only software out there in this group that does support units. Known units. I'm not going to say all units because some people make units. But just to give you some examples of that, and this last one's kind of cool. This is just showing the density of the hardware, and you realize how undense it is in spots. Visualizing. Yes, we visualize lots of things, pretty much anything. I showed you plots. I showed you a very basic plot. That's a kind of a much more advanced plot. But plots, parametric plots, contour plots, density plots, streamline, or stream, vector, polar, and region plots. Anything we do in 2D, we also do in 3D. So you can do all of those plots that way. And also data visualization like by bar chart, pie charts, sector charts, bubble charts, anything like that, we also do in 2D and 3D. And then specialized fields like electronic engineering, GIS, statistics, graph theory, medical imaging, wavelengths, control systems, and finance. So the language of the Wolfram language of Mathematica, is very easy to get started. And I told you the 3 rules, and those are there illustrated there, right there. But the syntax kind of moves in a very linear way, and it's very easy to follow. So if I want to plot that sign, I can do that. If I want to integrate that sign, I can do it this way. It's just basic functions that I keep changing. If I want to plot that in 3D, and again, I'm going to GLA, and zooming in on that, I can do as well. And then if I want to manipulate and put more than one of those plots, it's just to manipulate, and then I just find those functions and which functions I want to use, like I did before. So there's a density and a contour and plot 3D. Our built-in interactivity. This is something, again, that we do intuitively for you. So this is really stuff you don't have to program. Time saving, effort saving. So for instance, this whisker chart, you can mouse over and see the data that's involved in these flips. Tooltip is a command that we came up with in version 809, I don't recall which, but it's a nice little function, because if you do more than one plot on a graph and you just have those curves, those sine curves here, cosines, etc., you don't know which is which. So if you throw in tooltip, when you mouse over, it can show you which one's which. And then intuitively, again, this automation that we have is, I told you, the drop-down menu. Well, here, color functions. So if you have more than like this one, it automatically did that. There is no coding in it that tells it to change those colors. Branch cuts, intuitively, it knows that you do not have to tell it to not put grid lines in the branch cuts. And adaptive sampling, do not break down when oscillation increases, things like that. And then the general presentation of Mathematica is excellent. This, I think, is made fun of that. That's a pretty good job. I told you about this already. That's that classroom assistant palette. I won't get into that. Other styles and things that we do, like the keys and things like that, we do as well. This is just giving you an example of some pretty illustrations here. This is excellent to know. This, you guys, can take notes. If you come out, you do a graph and you say, okay, I want to annotate it. I want to put some stuff on it. I just don't want to have to program that in. You can do it this way. Under this graphics, drawing tools. This is so nice. So now I can just draw on that graph. I do not have to write code for this. I can just type text on that graph. I can, there's a lot of things I can do, change colors, thickness, arrowheads, anything. But also, once it's on there, it's just layered on there. So you can move it around and move it around. This makes life so much easier. Welcome back to this person. Now, another thing that we do that you may or may not be aware of, if you do a graph in Mathematica, keep in mind, not a manipulate, not a model that's moving and everything, because that you can only save as a CDF if you want people to be able to see those, work those models. With a static model like this or a plot like this, all I have to do, if I wanted to put this into a Word document or something like that, all I have to do is right-click on it and say Save Graphic As, and I can save it as just that one little piece, as a PDF, a TIFF, a JPEG, a GIF, whatever I want to use. This can work well with the software. And also, if I wanted to save this entire notebook, my entire Mathematica notebook, I would just say Save As. And I can do save it as another notebook, obviously, or a CDF, like I said before, we just send it to somebody who doesn't have Mathematica. HTML, a PDF, that would make it very static. But also, like that. So if you're publishing, that's a great tool to have in your pocket. Do you use it for that? See? I'm gonna look on this after this, because this has apps. We have a lot of apps out there. The Wolfram Alpha, obviously, but you can also get like little slices of alpha, like algebra, calc, things like that. So those are on that website, that Wolfram Alpha website. Here down to the bottom. Little apps. I'm looking for Pro. I'm gonna have to look for how to see it. I'll have to look that for it. Go into it right now. Anyway, a little further The enterprise is something that's much more commercial. I will get into a little research. Are you doing any parallelizing any clusters and parallel computing? Is it something that we get into?
The point of that parallelization we're doing with external partners, like I believe Colorado, with Boulders, with the card.
Okay.
I use their computer.
Okay. Well, it's built into Mathematica, so you don't have to buy anything else. It just parallelizes the functioning for doing cluster work. Another nice thing that we do for you is those NVIDIA cards that the gaming companies have pushed the computer industry into developing so that their graphics run beautifully. You guys are familiar with how nice the graphics are in the games that you use. Those NVIDIA cards are just number crunchers, and that's what we tap into to help run Mathematica as well. I'll let you go to these. This is just doing some examples of some parallel processing, so to show you how it speeds things up. You can go over those on your own. Programming in Mathematica is you can program in whatever style you want, which means that if you like to do things rule-based, procedural-based, list-based, however you want to do it, you can do it in Mathematica the way that you like to think. This I've already talked about because that's that auto-completion, the command completion here. There's other things. If you are defining functions, let me see which one is it. Yeah, if you're defining functions, and which you could do, and I did in that, I defined the functions for that one graph for the different cosine, sine, cosine, those functions. And I can't remember what I called it. You can do this and ask it to just a question sign, and I haven't defined anything yet. So it will tell me anything that I've defined that starts with letter F, things like that. So it's really helpful in that respect. We'll get into that. If you do or have done anything in C, you can download that into Mathematica now, and it will read it. Are we doing C, C++?
Yeah, we have classes on C and C++.
Well, what's the, is it Java that's?
And the Python.
No, the Mathematica will read it, doesn't read Python.
No. It would read Java and C.
And C, that's what Java was. So if you do anything in those, you can download those into Mathematica and you'll do that. This is just timing stuff. I'm not going to go into that right now. So I'll get into a little specialized applications here. Statistics being one. Mathematica has more statistical distributions than any other software out there. We like that. It's very easy to use and do. Here I'm just defining some data, and I'm just grabbing some random real numbers between 10 and 25. So just gave me 10, actually between 1 and 25, or 0 and 25, excuse me. But it's giving me just 10 numbers, and I'm going to find the mean of those numbers. And if I want the variance, I just tell it what I want. Take that standard deviation. Here's just some new data, etc. So it just gives you an idea of what it can do in those statistical analysis. Here I can grab that plot I did earlier, and now I want to do I want to fit a model to that data and see if it's going to fit that. The data is going to fit that model. So I'm going to define my model here, and I'm going to pull out that list plot and see how it fits that model. In other models, we have these properties of the models that we do. And ANOVA, of course, is one, and there's the example of that. I'm not going to get into the probabilities because it's so basic. Symbolic examples, I mean, you can do Poisson distributions, etc. Coin tossing, this is something that all you freshmen have probably done, or as freshmen, I don't know what you guys are in. But the coin toss and probabilities of heads and tails, well, now Mathematica will toss the coin for you. Yeah, you don't have to flip the coin. So again, CBM, computers do it. Let's see. Let me move down here. So this is just an illustration of the statistical distributions, and that was in version 8. We're at version 10. We have more now than that, but we still have more than SPSS even, which is solely statistical software and SAS. And this is what some of our visualizations look like, our charts and data distributions. So there's a density, so you can see histogram density, line density, point densities. Those are some of the things that we can do with this group. And QQ plots, of course, probability plots, and comparative bar charts, etc. Okay, other applications. We don't have anybody. Do you have a finance department, business department?
We have a business department in St.Thomas.
And is it something that they would want to use? Or would you be able to talk them into trying it?
I might try.
We do some nice things for them if they would like to try it. This is, I mean, just financial data is to die for on Mathematica. It's live. It's constantly tapping into the stock exchange. This was just, what I'm pulling up here is IBM raw close data from 7/1/2008 to today. And so it's charting that right now in a KD chart right there is what I just did, just so you know. And here's that same data in a line break chart. And here's that same information in a rank code chart. So just different ways that they like to chart things. But this last one is pretty darn cool. So this is Apple from 2010 to date. And this is just an interactive trading chart or something like that. This is pretty impressive because you can adjust the block of time and different chart types and different indicators. So it just gives you an example. That's pretty major stuff there for finance. I've never done something like that. Anyway, image processing we do as well. Very happy with this. If you're taking, this might be something that you would be using when you're taking pictures with your microscopes and things like that. I don't know if you've ever tried it, but you can process images. I have one chemistry partner buy it for that reason. They wanted to be able to adjust pictures and do some of this. Sort of show how many face detect is one of the things we're doing. Actually, we're doing face recognition software as well now. That's going to be big. Yeah. Well, we're actually, this is kind of cool. We're actually doing image identifier, image recognition, okay? Orkin bought us. Orkin.
Really?
Okay, let me tell you what, this is kind of cool. They want to do image recognition for bugs. They want to develop an interactive website so that people can take a picture of their stupid bug in their house, download it onto their website, decide what bug it is that they want to kill so they know what to tell Orkin that they need, right? Isn't that funny? I thought that was the coolest thing ever. Yeah, so it's maybe not face recognition, but it's image recognition, and it's bugs. I love it. And the more pictures, and they're just downloading right now. That's what they're doing. They're just downloading picture after picture after picture after picture of all kinds of bugs that they can find, and they're putting that on their system, and that's going to be the future for them. I think that's a great idea. How many times did they get called out for an ant, or something stupid? And okay, so that's image, image processing. That's a big picture there. Let me get text recognition. This is just more graphic arts type stuff. So music and art is part of Mathematica. I didn't do a demonstration in that database of models, but yeah, a lot of people have used Mathematica for that sort of thing as well, just to make things look cool. And something like this. Okay, this is just going to twist this, so you can't see that skull at the front. That's the skull down there at the bottom. So it's just doing things like that. Edge detect. Here's my story. I saw this demonstrator, this edge detect illustration, and I thought, graphic arts. I did not think about it far enough until Christopher Wolfram did a talk at a conference. That's Stephen's son, Christopher. He was about 11 at the time. And he flew a quadricopter, and he's seen this demonstration. He flew a quadricopter around the room and had Mathematica running the flight path. And when he got to went to land it, he hit the desk. And I thought he was going to run out and cry. I really did, because I would have. But I'm not a Wolfram. And he goes, oh, I forgot edge detect. Gets up, types it in, runs the pattern again, and it just went and landed. I'm like, okay, drone technology. There's that application for that. So yes, and we know that Mathematica is being used because we are big with NASA, Air Force, Marines, Navy, everybody is using Mathematica. So yeah, I'm fully convinced of that. Anyway, some other things, this is kind of an edge detect kind of thing, but it's a line, image lines. This is in astronomy. This is very cool. This is an image of the moon, 2 images of the moon, and it's determining corresponding points. Lines on those 2 images. Wavelets.
I know, we don't do it.
Okay, good. I don't know about it. Control theory. Control theory. Let me get into some other things here. System modeler. You're an engineer?
Yeah, system modeler is. I have in mind when we get much better.
Okay.
Financially. So
I did read brochures on it, so please.
yeah, so
grab one of those.
for
This is a simulation tool, and this is an actual separate software from Mathematica. We purchased Modelica software. This is actually we purchased this company designs like Audi and BMW. It's a European company, so they do things like that. So it's taking systems and putting them together so that you can, like, this is an example, F-350 truck. Okay, so I want to model, this is a model of, I can't remember which part of it looks like the drivetrain of the truck. And you can pull, there's libraries over here, so you can pull out whatever component of that you want and start building your truck. Okay, and then you can run that simulation and get results in bar chart format, etc. And then the ultimate thing then is when you get data from running these simulations is then you can dump them into Mathematica and analyze that data as well. So you have these 2 working together. So we wanted to have a real simulation software as well. And this would be, we do biological functions too. So saving rats and rabbits and animals. This is just how insulin is processed in the system after eating. So that's what that's illustrating. But we have all kinds of things, on all kinds of systems, all kinds of libraries. There's tons of things you can do with the system modeling. Okay, I'm going to show you that's already done that. A little bit of what's new in 10, because some of this stuff isn't in the slide deck, but some of it I've already done. Well, I didn't tell you about multiple undo, that was new in 10. You can undo things, you used to be able to do that. Time series.
that one we're doing a lot.
Oh, really? Time series?
Yeah.
Well, this is temperatures. I'm not exactly sure what this is illustrating, but let's try it. And then it's taking those plotting those time series. This is a model fit. I'm not real familiar with these two. This is probably meaning more to you than me. So time series forecast. So you plug these things in, and where do you get your data for that?
Yeah, that's what I'm getting, like health data. I'm getting meteorological data.
Oh, okay.
There's 2 different time series, and you want to correlate the 2 time series.
Oh, okay.
To see
Gotcha.
if there is any correlation between them.
Let's see, edges do that. This is kind of cool. This, if you can do this geographically or map type of thing, what they've done here is pixelated Mona Lisa, and then they're trying to find the shortest route, shortest tour they call it, is the function name. So this is a pixelated picture of Mona Lisa, and this is all one line, finding the shortest route between all of those pixels. So it's kind of a cool idea there, but if you can think about, okay, I want to find the shortest distance on a map, you can do that as well, because we do have data, geographical data, but you can do that. And also, just external devices like Fitbits, GPSs, things like that, you can hook into Mathematica now as well to do that sort of work, so if you want to do something like Some of this stuff I've already done. I'm not going to do anymore. This is just a very kind of an example of some of the data that you wouldn't expect us to know. But buildings in the world, tallest buildings. So this is comparing all of those buildings. Machine learning. I talked about this just a little bit. Image detection, learning that. So they're just putting in all of those pictures and defining those pictures, right? This is kind of the same idea. They're defining numbers, and you can see it is 9, that's 9, blah, blah, blah. Okay, so now what I tell mathematics, I don't want to use this one. This is funny because it doesn't know it. Oops. How do I get that first? And it says it's a 7. So what I'm going to do is get rid of that one. I'm going to draw my own. That. And now we're going to use my Anyway, so yeah, and if I had put in a 2 that looked like that other one into this learning process up here, it would have recognized it. Good job. Anyway, moving on. And one new text. Geographic. This is just plotting routes basically, and I'm finding the cities, and one went from United States, via South Africa, so it just is showing where that's going, and then those big arrows in there. And this is GPS type stuff here. It's just connected to a GPS, I think with somebody's Fitbit or somebody's device like that, and doing it. But this is just mapping it, but you can analyze all kinds of data from that. You could see how fast you're going on every segment and find segments, and you could see how much elevation there was on each of those segments and things like that. So you can do a lot of information into that. This is that same surface plot for that. I'm going to show you that. So like that. Okay. One thing I want to do here real quick before I go is this is our webpage again, Wolfram.com. One thing that I like people to look at is where it's being used in the world. Math and physics won't be here because everything is math, everything is physics. But when you get into, defined areas that people are using Mathematica, chemistry would be one. And when you get on these solutions pages, they'll give you a few illustrations of some nice models and things like that. But it also, this is the good part, it gives you the Wolfram edge, what we do better, differently than others or better than others. It also will give you some videos of people that actually use it in the world, and this is actually academic here. And then some of the companies that are using it, it's usually just a very short list down here, it gives you an idea that you are going to see it again. So 3M, Alcon, Chevron, ExxonMobil is very big around here, I'm sure. Los Alamos, all of the national labs that I talked about earlier, things like that. We've got there. NASA, what did I tell you? NRAO, that's at NMT. All these sorts of things. But anyway, it gives you an idea. And one last place that I want you to go to when you get started, or if you're using Mathematica and you're trying to get started, is this Support and Learning Center. Right here, there are video screencasts, guys, that you can use that are excellent. There are hundreds of them to get you going in different ways. This is how to use CDF, Quick Tour, Mathematica. Some of these other ones are better. Hands-on Start is one of them. Actually, we just came out with a book on that. Did you know that? Hands-on Start came out. We published a book, and it's all about this getting started in Mathematica. can do that. And if you buy the book, you also, and I'm not trying to sell it by any means there. If you buy the book, it's actually available on Amazon. If you buy the book, you actually in the back will get a like pass or a code to use to take the live webinar of it as well. So that we can periodically. So and we're doing it. We're trying to do it like every month. So, anyway, I think that's everything. Unless you have some questions.